Sorry. Okay, looking for my PowerPoint file. Okay, this is where we stopped last time, Monday. Is regarding the basic concept about single inheritance. Especially we're looking at both how to declare a inheritance relationship and how to access to, say, the parent object. And similarly, later, we'll show you example that how from parent, you might be able to access to child. So it's interesting, the child, you can access to the parent. But what do I mean? The parent can access the child. Okay, the reason is this, is that when I declare a child class, say, for example, the child class is IoT thing. But remember, inheritance is a relationship. So therefore, IoT thing is also a thing. And therefore, it's not really its parent, is the portion that you inherited from the parents. And the thing is, it's kind of funny. This is a concept sometimes confuse people, is that when we actually treat a class hierarchy or object from a particular class, and we're not always stuck with one level of the class hierarchy. And sometimes we want to move up. For example, I say, I have this thing, then I call IoT thing. I mean, I might have the other thing I call cool thing. And maybe I have another thing called anything. So they actually have a multiple different child class from the same concept thing. And the thing is that that particular parent class thing sometimes is a uniform or universal representation that share by all the children at that point. And therefore, sometimes when I want to apply, I might want to move up to the thing level to process, so I can deal with not just about IoT thing, I can actually deal with anything and the cool thing as well. So we'll see that in object-oriented programming, sometimes we have to move up and move down. That's actually confusing, to be honest with you, because sometimes you know, well, how should I move up? And more importantly, why should I need to move up? And the thing is that once you move up, you actually is a thing. But now I'm saying move down. I mean, if you're IoT thing, you know your parent is thing. But if you're a thing, once you move up, in the view of this object became a thing. And now how do you actually move down? Because how does the programmer know whether that was actually originally was a IoT thing, was anything, was a cool thing? Once you became a thing. But it's interesting that object-oriented language has to provide you the mechanism to both move up and move down. And that will be the topic we're going to starting to address today, which is, I would say this is probably one of the harder content about this course. And the second thing, go with this up and down mechanism is that, well, from the programming perspective, yes, I have to do that. But from the C programmer perspective, I actually need to worry about something we call memory layout when I actually implement an object. So within this class, I'm actually also, probably not today, I'm going to start on Friday. I'm going to start to talk about pointer, the C pointer, because C pointer is very essential for you to understand how can I actually move up and move down. Java programmer, Python programmer, they don't have to worry about this because they have a totally different mechanism to process this thing. But the C programmer, you need to actually handle that. And that handling mechanism is part of your homework number 3 as well. Okay, so that's why I'm actually start into the content about the core of homework assignment number 3. Okay, so I want to actually end this part before I start a new part with this picture. From this picture, it looks like is a single inheritance relationship from the base class and the derived class, or parent and the child class. But there's a few questions as a programmer or as a designer, we have to keep asking ourselves. Sorry, I have to move this a little bit down because it was blocked by the command window of Zoom. Hopefully this will work. So the first question as an object-oriented programmer always have to ask when we deal with inheritance. The thing is that who are really you? Think about this. An object is a living creature. I'm serious about that, okay? It can think, it can respond, it can actually do a lot of things. That's why a kind of artificial creature. And the thing is that who that particular creature really is. It's the base, yes. It's the derived, yes, they're both. But the thing is that how do I really define what it is? It's going to be related to how I'm going to interact with that. For example, if this is a hierarchy with, we use an example, community member, and then we have a teacher and student. So student and teacher are both derived class from the community member, as I showed last time. But the thing is that when I'm dealing with this object, I need to actually understand whether I'm dealing with is a student or is a teacher, even though at that time, it looks like it's just a community member. Because the way I actually treat a teacher and the student might be somewhat different depending on what kind of context we're talking about. And the thing is that the other thing which is important is that the object itself might want to change the view. I mean, right now we're saying that, well, depending on who you are, I'm going to treat you differently. But the object itself, as a programmer perspective, can actually change its outlook in such that it looks like is a different role in the class hierarchy because this object wants to be treated that specific way. So for example, a student, it's a student object, but at the time, under certain situation, it wants to be treated as a community member. So which I'm implying, there is certain function that's actually the same with the same interface, but the behavior is different between the community member and the student. So there is a choice we have to make. This actually makes object-oriented very interesting because it can model a lot of situations that we would like to have. And the thing is that what I show you is that we in fact has a multiple view, because even though you're a student, you're also a community member, and maybe you're an employee as well. So you actually have a multiple view. And so in that case, how do you actually control and manage that view and such that your program can actually exactly behave like what you want to have? Okay, I'm actually going to show you this one. All right, I'm actually going to show you this mechanism going up, going down, and then the behavior. I'm actually going to use this example still, base and derived class. And I'm actually going to design a function. And this function is called foo. Okay, later I will change it to something else. But right now, let's just worry about, there's a function called foo. It's a member function I define with the base. I also define the same member function with the derived class. So idea is that one of the member function, foo, is actually designated for community member in general, which the other member function foo is actually designed for student view only. So assuming we have these two different functions defined. So this is desirable because this actually creates two different views for the same function. When you actually call foo, it depends on what is the data type at the time when you actually invoke the member function, then it will actually invoke one of them.
Professor?
Yeah.
When we use virtual for C++, we use it with base class. So when the child class has to override or implement the function, any virtual function, is that correct?
Yeah, I haven't actually talked about virtual. So I'm actually going to talk about virtual right now. This is the first time you see that. Alternatively, I can also declare the member function with a keyword virtual in front of that. So I have a two-way to specify foo. One is a yellow way, which is I don't have the keyword virtual. I just say this is a function foo. And then the other, I'm actually using virtual to add that keyword. Okay, so I'm actually telling you there's a two different way you can specify a member function under a single inheritance relationship, and they're going to behave differently. Obviously, the virtual is going to do something. So this, when you have a member function, you add the keyword virtual in the front, this becomes what we call virtual function. But the thing is that what we want to learn is that what exactly virtual function does for us, what exactly it does differently to our code. So that's something which I would like to learn. So okay, so let's actually use this piece of code. Let's look at non-virtual function. This is a regular function, and I'm going to ask you some questions. So I have a foo that's declaring base and the foo declaring derived. And look at the code. I have about 5 lines of code over here. So I declare a object, which is my base. I'm assuming I'm using default constructor. There's no argument. So this one, the first line, my base obj1, is going to create an object that's actually belong to the base. And I'm using the second line, my derived, object2. So basically, object2 is created like this. So in my previous example, object1 is community member. Object2 is the student. Okay, and obviously, if I call object1.foo based on the non-virtual function, I will actually ask you the foo function that declare here on the top. And if I use object2.foo, it will actually call the member function implementation at the derived class. So I hope the first 4 lines, you're okay with that, right? You understand the behavior. Depending on what's the type of that object, when I actually invoke the member function, it will actually execute correspondingly to whatever the implementation. Okay, so now I'm actually going to ask you this question. This is a little bit tricky. So assuming I have object2, what's the type of object2? Base. No, object2 is not base. Object2 is derived, right? So I actually, this is called casting. Some of you probably heard me saying that already, but this is in C or C++, it's called casting. So casting is a way for me to move up or move down. So when I cast, it can move up, it can move down. So later, for your homework assignment number 3, you actually know sometimes casting could be dangerous. If you're a C programmer, you probably know that sometimes casting will have some unexpected behavior. So usually this, you have to be careful. So when I did this casting, what it does is I convert the object to a different type, from derived to base. So my question to you is that if I write the code looks like this, I cast object 2 to a different type, and then I call foo. Which version of foo should be executed? The base. Okay, good. Is that everybody agree? Okay, this is important. Yeah.
Casting, will you always use the ampersand when you cast object 2 to a different type? What if you just put my base object 2?
That's a good question. I don't think that it's going to make any difference. I don't think so. But unless a different version of compiler, they're going to check for some kind of newer version. But when I did casting in C++, I usually, as I remember the older version, I don't have the M sign. So at that time, I didn't put anything. But don't trust me, even I don't trust myself. I have to write the code. Later, when we go to the coding session, let's actually look at what will be the different version of the compiler my complaint. Yeah. M sign really means reference. So usually in C++, if I use like an argument without the M sign, is usually a concept called call by value, meaning that I'm actually copy the value of the object from the argument to whoever receives it. But if I put an M sign, it becomes what we call by reference. Call by reference means that we're actually using the same memory footprint. I'm not actually making a copy, directly use them. So it used to be the older version of C++ doesn't have reference. All we have is a pointer, which is the address, and the value. So call by reference, it has to be pointer. Call by value is like a remove this M sign. That's the difference. But I forgot which version of C++ they started to introduce the M sign, which essentially is trying to help us to do call by reference without understanding about pointer itself. Essentially, you can do reference. If you think about what is reference, a reference is a pointer. So essentially, they want to achieve the efficiency of pointer without using the kind of panicking syntax of pointer. Okay, by the way, if those of you who actually survived from ecs36b, I think almost unanimously, all the students determined that pointer was the most difficult topic for the whole ecs36b. That could be wrong, but it's just my impression when I taught ecs36a. Okay. All right. So we're okay with this slide. All right. I'm going to use a different way. So essentially, that's the answer that just show you that object 1 is actually the third line, go for the base. The second line go to the derive, and the third line go to the base. Okay, so now I'm actually doing something different. So we're going to compare. This is a virtual. So I actually declare both foo at the base as well as the derive. They're both virtual. And then I still use exactly the same code. Now this 3 arrow, where do you think they should go? So if I call the first line number 3, this line over here, which version of the code it should execute?
The base.
The base, okay. The base, yes, it is base because it is a base, right? The second line, how about the second line?
Right.
Okay, the right, so far so good, right? They're the same. If you look at this, they are essentially the same. From here, let me see. From here, this is a oh sorry, where's code? Oh, code is here. You see that the first two, one blue, one red. The same with this one. The difference is the third one.
Calls the derived plus is the one-time polymorphism.
Okay. So depending on how we want to interpret the behavior, I want you to actually take a look. I want you to first understand the impact of the virtual to the program behavior. But then you try to guess why adding virtual. What's the rule about the virtual function mechanism?
What was the question?
The question is, how do you actually interpret the behavior of this? I mean, the way I said it like this, my base and object two. Why is this will not change the behavior? In other words, maybe I should ask you the same question is that, what does virtual change the decision-making about which function I should actually execute?
So the object two was not casted as a different type, that it points back to the right base, right?
Right.
But the reason for that is because the where it's where the object is in memory, it points to the address.
Okay, let me give you an example. Let me give you an example like this. Okay, I'm actually going to copy this pipeline. I'm going to do something interesting. And it might looks a bit ugly, but it's okay. I'm going to do this. I'm going to first to say, I'm going to just there's a way I can get this information, but I'm not going to just put it here. Is say, assuming the address, the memory address of this object two was, say, has a decimal 71141346. Okay, assuming that's the memory address of object two. Okay. And now I'm going to write a piece of code like this. I'm going to write this piece of code. I said my base star obj3 ptr is actually equal to my base star 0x711411346. Okay, I'm actually declare a pointer to the my base. And I'm actually fitting the address of that object to numerical. I'm actually just treat it as an integer, and then I feed into that. And then I'm actually say, hey, I'm going to do I will use this syntax instead of using that. I would say obj3 ptr dot foo. Okay, let me actually look at this. This two lines of code I just add. I hope you realize that this code is actually very similar to this code. This line of code, very similar. I'm actually treating as an integer. By the way, that integer I might not declare in that scope. It might be passing as a function, as argument from a remote machine. I just send, I know the address, and then I send this as a 32-bit integer So essentially, when I ask you this code, I have no idea what was what? What was the type of the object? I already lost the type of object. For this code, you might be able to, if those 5 lines of code is in the same function, I can still track what is the original type of object 2. But this code, I actually lost that. All I see is a pointer to my base object. So my question to you is that if I actually run this code, so by the way, star obj ptr is the same as obj2 dot foo is the same. Which function do you think this actually should invoke? The base or the derived?
Did you arrive because you didn't pass anything?
No, obj3 is my base.
Okay, so we don't have any virtual functions here, right?
It's virtual.
Then
Who is
we'll
virtual?
We'll call, for virtual functions, we'll call the derived virtual function proper.
Are you sure?
Think so.
Okay, we have 2 possibilities. This is actually a derived, or this is a base. I kind of slow down a little bit because this is so important. It will call the derived. It will not call the base. Even you strip out all the type information, it looks it's an integer only. It's an integer. Maybe this, by the way, I actually wrote this piece of code. I actually type in this number. So I actually typed in the memory address from standard IO or from CN. And then that address is being casted into a pointer. And then I start to use that as an object and calling a virtual function. And still is actually going to call the derived that we show here. Looks like this. It still go to call the derived of foo. So, okay. So now after I show you this example, number 1, I want to make sure everybody understand what the example is telling you about whether you should make a decision, whether it's called a parent or it's called child. That's number 1. Number 2, I want you to actually come up with a definition for virtual function. I want you to come up with a definition. What do I mean by virtual function based on the example you just see? Why don't we do this? Why don't you guys talk about your neighbor for about 1 minute? I give you 1 minute to talk about. I think you might be able to come up with some interesting idea. Because I want to take it slow because this is pretty important concept in the whole C++ polymorphism. Okay, why don't you talk to your neighbor for 1 minute and then I will solicit your help.
Okay, so
Yeah, I did in high school.
It's a virtual function, virtual member function.
Why would you do that?
Okay, let's see if anybody from this side want to provide what you think. Come up with a definition for virtual function. Anybody from this side? Yes, please.
Get rid of typecasting or like passing up and down to see what inheritance like the starting object you have, like those whatever functions are maintained?
What do you mean by starting?
Well, like in this case, I guess starting would be the derived object. And then
Okay.
It's functions as you.
Good. So that's a good one. Okay, so hold on to that thought. I want to see this side, the far right side. Anybody here want to come up with your definition? Yes, please. A function can be rewritten. Okay, that's good one. Okay, that's good. Remember that thought, rewriting. Okay. I think I got enough in. So middle guys, sorry about that. I know you guys have a perfect answer, but I'm going to skip it. Okay, so I want to tell you is that it's actually a combination of both of you. Both of you actually hit some point into this. The first issue is this is if it's non-virtual function. By the way, it's a non-virtual function. So when I actually determine which function I'm going to call, is actually at the time when I make a call. What is the class type of the object at the time when I make the call? Okay, at the time is very important. If I execute this line of code, at this time, I want to see what's the type of this object. It has been casting at that time, I'm called. So that's why that determines which version I'm going to call. But virtual function is when you say starting, I'm actually using at the time of creation. So instead of, if you remember previous slide is at the time of the call, but here I change it to the time of the object creation. What was the type when you create the object? If you create as a derived, it will be called the derived version. If it's created as a base, it will go with the base. So regardless how you actually change the formality, even you convert everything into an integer as an address and you come back, it still will try to count how this function was actually created. This may be created 1 second ago, maybe actually created a week ago. It's still there. So it has been transformed 2 million times, but I still need to remember what was over there. So now it's very tricky. Well, then this actually has an imply to the programming language, meaning that the runtime support, not the compiler, has to remember what was the type that this particular object was created, and that information needs to be put in with the object itself. So I can actually remember that. So this is actually, later you will see the implementation, you will say, oh, that's the way it's implemented. But I actually want to give you a summarization. Think about that. In my implementation, I must remember what was the original type that when you actually create this object. And somehow that knowledge is a runtime, it's not compiler time. Remember, we have a preprocessing, we have a compiler time, but this part starting to be runtime because the creation time I cannot determine easily by compiler. Compiler can actually decide this. This is easy for the compiler because it's the same line of code at the time of the call. So this can be done in compiler, but this cannot. This must be done at runtime. At runtime, in fact, we use the word rewriting. Yes, they actually do some kind of rewriting at runtime to actually associate the right, what I would call the function pointer to the member function. So it will call the right member function. Yes.
Does the association with the base virtual function survive even if you do like a move initialization with the object?
If you do move constructor or move assignment, it will survive. The virtual function, whatever if you move, right? If you move a base to another object, and it doesn't matter whether it's a base or something, the virtual function association will still be there. If you move a derived, then whatever you create, that association will remain the same for the whole lifetime of the object. If you use move, if you use a copy constructor, then it's not. Because copy constructor, depending on at the time when you do the copy, are you copy as a my base or copy as my derived? Then it will, it's because copy is considered as a creation. Excellent question about the move. Yeah.
Does casting just not work when you have virtual functions, or like how?
It's not really casting doesn't have an impact. So the reason I show you this is that several people misunderstood the C++ virtual function is saying that, oh, in C++ virtual function, casting is not going to have any impact, have any effect on the behavior. The core reason is not. The core reason is not because you casting or not casting. Because in this case, casting does not make any impact or effect. That's true. But the true reason for the virtual function to decide which one I'm going to call is really determined by the time of creation. Is regardless you cast or not cast. It's not, so cast and not cast is just saying that it's not going to affect the result, but it's not the root cause of the result either. The root cause of the result, very important, is actually at the time you create this object, what's the type? And for example, the kind of ugly code I show you, you see that I create the object 2, and I kind of forget about that. And then I only remember the integer, and that integer is a memory address, assuming that memory address still exists. Then I'm just using that memory address and doing whatever casting I want, whatever format, but in its blood, it's still being created as a derived. Then I'm going to call that derived.
So if we had like another function or another function for obj or my base, the new casted object can access whatever none of the functions were in the parent as well.
Right. If you create my base, it's a my base. So virtual function is essentially saying that if you create as this class, the behavior of this will always be that, even you convert its format. So now I'm actually going back to use the example of a student and the community member. I'm saying that when you create an object as a class student, and you convert it to community member, and mixing with all other community members, such as teachers, such as other personnel at UC Davis. But when I actually make the virtual function call to the community member, it will always go back to student, exactly. Because it determined at what class you created. Yes, please.
Do both the number function of the base class and the derived class have to be virtual?
Yes, both of them have to be virtual. If only one of the virtual, that it will be override by the other one. Yeah, both have to be virtual. Yes, please.
Third class, let's say that my base was a derived class from my super base, and you made a pointer, like, say you have my base reference object 2. What if you captured that into super base?
No, I don't. It will be still the same, because when you have that, let me actually show you an example. I'm going to cover this. Anyway, later I'll show you this. So here I have the hierarchy about 4 super base. Core, thing is a core, IoT thing is a thing, and proxy IoT thing is IoT thing. So I have a 4-layer of derived and the base, right? So assuming I'm here, this blue layer, and I casting all the way to core. And now it looks like it's a pointer to a core. But when I invoke the virtual function from the core, it will actually drop down to proxy.
So it goes all the way.
It will all the way, yes, yes, it will all the way to the down. So you can see that this mechanism is quite powerful. If you know, if you have two options, if you don't want to be virtual, then whatever the type is going to mandate which virtual function. But if you want to use virtual, you know it's a power. Because regardless how deep your inheritance hierarchy is, it will always find the right place, even if you change the object to a different format. The only thing that's actually you need to learn as I would call it advanced C++ programmer is that you might want to learn how C++ remember that association with the original class that it created, because that information is essential for me at runtime to be able to call the right version. So this is an important concept. I want to tell you two things before I introduce pointer. Because pointer will be even clearer or more difficult to understand. So the regular member function is a compiler concept. It's a compiler concept. So I know already which code I'm actually going to ask you if it's not virtual function. I already know them. But virtual function is not a compiler type concept, meaning that you have to wait until runtime to determine which function you're actually going to call. Right? It makes sense, right? Because when I have a pointer, I really don't know. The compiler don't know which function. It could be core, it could be thing, it could be IoT thing, could be proxy IoT thing. I don't know. So number one, you have to remember that information. Number two, because it's a runtime decision, it's actually going to be slow. Performance is going to be slow. So essentially the mechanism is for indirection. So the answer from the right side is saying rewriting. It's essentially a rewriting of a function pointer at the time of creation. So the thing is that it's not determined at the time you call it, but at the time you create it, it actually set up the right function pointer. Remember I said the concept of function pointer at the beginning of the quarter. I mean, most of the ecs36b instructor won't cover that because you don't need to understand function pointer unless you need to touch the concept like a virtual function. So that's why I want to talk about that. Does that answer your question? Okay, yes. Okay. Runtime and compiler time is the following. Compiler time is you actually take the .c code, you generate the .o file, you generate the executable, can read that out. So everything up to that point is compiler time. So compiler time, the purpose is generating that executable. So essentially, when you look at that executable, it's already telling you that you're going to execute this particular version of the function. So that's called compiler time. Runtime is that you have to run the program, and when you type /eval, that became the runtime. So at runtime, the program itself will actually do something to figure out, am I core, or am I thing, or IoT thing, am I proxy IoT thing? So I just want to tell you the mechanism the runtime did is at the time you create the object, at the time you create the object, not the time you call it. The time you create the object, at that time, you actually rewrite your function pointer. So then when you have that, you call that function pointer, it's already there. So that's kind of a little bit messy. That's very unique to the C++, both in terms of their definition for virtual function and their implementation. How do you do this kind of binding? It's a dynamic binding, essentially. That's why virtual function is not fast. Because if you don't use virtual function, I can do a lot of compiler optimization. But because you're doing an ugly code like I show you, If you think about this, if I write a code looks like that, I'm not actually recommend student to write this code. I'm just illustrate the idea. If I actually write a code looks like this is how does compiler have any idea to optimize this piece of code? There's no way they can do that. Okay, so that's why the compiler cannot do anything. And this is usually some kind of function pointer indirection before you execute. I mean, the performance for most application, it doesn't matter. But for some application, if they do this a lot, that become overhead. Yeah.
When it comes to like function pointers, the function pointers always invoke, like even like we create an object.
Function, okay, good question. Function pointer only is involved when you have a virtual function. Only involved. If you don't have virtual function, I don't need any function pointer. Yeah. Well, I do want to say that the compiler actually know when you call this, if foo is a virtual function, the compiler doesn't know what is the object of the original type. But the compiler know that this function is a virtual function. Therefore, compiler will invoke the function pointer mechanism. Okay, that's a final detail about this. Okay, any other question about okay, so I actually cover very important thing that I would like to cover. So I think it's 4 o'clock. I want to take a break. And this will be the discussion today, starting in 10 minutes. I will actually show you the homework 3 directory, the code I gave you on Monday. But there is a virtual function called dump to JSON. We're going to see that code in detail. So you actually can see a realistic code, how virtual function is used and why it's used in a real application case. Okay, so just let you know that we're going to starting I mentioned that we actually talked about chapter 13, chapter 14. So chapter 13 is about inheritance. I haven't covered multiple inheritance, by the way. I'm just covering single inheritance. I will come back to multiple inheritance. But I actually go to 14 to talk about polymorphism. So polymorphism is C++, sorry, virtual function is a C++ way to realize polymorphism, just like you know. And I'm also cover chapter 6. If you're reading, you can read chapter 6. It's about all the pointer and the reference as well. For the midterm, I'm not going to ask any question in chapter 6. I only ask question from chapter 11 to chapter 14, but I'm going to ask some question about what I covered in this lecture about virtual function. Okay, just let you know that. Okay, let's take a break. Okay, I'm not going to continue with this slide. I will continue with this slide, talk about the concept of pointer. So I just want to flash. I start to talk about the linguistics, about C and C++ pointer. This is going to be Friday. What I want to take this opportunity is actually looking at the code that I share with you on Monday regarding the virtual function. And then the remaining time, you can ask any question you want for any of the homework. Okay, let's actually go to, let me just open the window. It's easier to do it that way. Okay, so this is the code I show you Monday. I want to first look at thing.h. So in thing.h, you can see I have this function called dump to JSON. And I currently set it to be virtual. But as you just realized that it's actually very critical important for you to understand the meaning about the virtual, it actually has some impact on the result. Okay, so let's actually take a look at the thing.cpp. So in thing.cpp, I have this function called dump to JSON. So number one, I want to tell you that you only need to say virtual in the .h file. When you do the implementation here, you see I didn't add a virtual. So the virtual only at the class specification, but not in the function implementation. If I want to do separate compilation, just clarify that. So for this dump to JSON, that's actually belong to thing. I actually print model, sequence number, description, and owner, and a bunch of other things related to the thing. Okay, so let's actually take a look at IoT thing. If you look at IoT thing, I also have JSON value, dump to JSON. I also has a virtual. And then I want to take a look at IoT thing.cpp. So let's actually take a look, dump to JSON. So essentially, this is a little bit messy, just like you know. But I want you to see that here is the way I actually move up. So when I actually print this, I actually want to print both the JSON in the parent as well as the JSON in the derived class. I want to do both because each of them has a part of information I want to dump. So that's my purpose. Unfortunately, in C++, there's no such mechanism to allow me to actually invoke both the parent and the child, except when they are constructor. So I cannot easily do that. So this way, I actually declare as a parent, declare as a virtual, but you look at what I did. I actually create a object called thing. So this is object creation. And how do I actually create it? I use copy constructor. I use copy constructor. You see, this is this. This is the child. And then I casting, well, I can do IoT thing. I can cast anyway, but the copy constructor is actually copy into the parent. So when parent was created, it was a thing. So then what I did is I actually inside here, I call parents dump JSON. And I include that result. And then I actually call my own part of JSON, which is the only difference between IoT thing and the thing, if you remember from last time, is this attribute called connected. So basically, this connected is what? Is a IP address. So I actually call the IP address of the dump to JSON, and then integrate these two results together using this line. This line is really include the JSON I actually dump from the IP address, and then I put result connected to that JV result. And then this will basically integrate all the JSON together. So I have one part of the JSON from the parent. One part is from me, but itself is an object. So I have to call IP address, and then I actually integrate all of them together and return this. Okay. Yes.
Are dump to JSON files just like printing statements?
No, dump to JSON in this function is just construct, instead of printing to the output, is actually produce a JSON value object. So you can think about JSON value object is a C++ representation about a JSON. It's a C++ representation. It has a library It's called JV value. Basically, it's a JV value. Just to let you know that the important thing about the include file, if you remember the ecs36b comment.h, there are 4 lines over here, which is this 4 line is essentially supporting the library we're talking about. The JSON.h, value.h, and things like that. And those 4 lines together with your make file, I think one of you asking me a question about the make file. The make file, I have a LD flag, which is linked to the library about JSON CPP library. It's a standard library. I mean, C++ has a lot of library, but the JSON library happens to be one of the most popular one that the C++ programmer use that a lot to handle all the information. Okay. All right, so that's how the virtual function is done. Let's actually look at the code itself. So if I do this, look at the code after I did that virtual implementation. So now everything is the same, except I'm actually doing a little bit here. So now you can see when I actually create the Swedish meatball. So Swedish meatball is no longer a thing, but Swedish meatball in this program is an IoT thing. It has an IP address. That's kind of cool, right? When you eat the food, it's like a tracking where the food, where's the food go to your digest system. I believe that will be available very soon. And after you've done this Swedish meatball, remember you see here, I actually call this function Swedish meatball.json. And what is a Swedish meatball? Swedish meatball is IoT thing. But here I can actually do all kind of casting because it's declared as a virtual. So I can actually casting this as thing. And it wouldn't matter because the function actually I should change like this way. I should change it this way. This is the right way to casting. So I casting this into a different type, which helped me to move up. And then I call that function, but because the virtual, it will include that connected. Okay, connected is IP address. Let's try to run the program. I want to show you the difference, okay? Okay, I compile it and I run it. Hold on. Okay, you generate a JSON and you look carefully. Where is the IP address? Did you see IP address somewhere? Why I lost it? That's interesting.
So we expect to see it because.
Yeah, we expect it because it's the virtual function, right? Let me check. Let me take a look. It should be here, right? It doesn't have it. So let's actually take a look at the code. What happened? Let me actually check again. Let me do the make clean. Just make sure that it's actually executing the right version of the code. That's strange. It's gone. Okay. Now I have an assignment for all of you to take a look at the code. What's wrong with it? Did I do something wrong? IoT thing, switch meatball. I did a casting. Oh, you know what? I didn't cast as called by reference. I actually call by value. So I should do this. I casting as because I don't want to do a copy. I want to do a reference. So if I do this,
Copy and overwrite.
when I without that n, this actually create a new copy. Then it become the thing instead of IoT thing. Yeah, I forgot about that. Okay, so now you can see I should have, yeah, you see now I have connected, right? So when I casting, so I think you asked a question earlier in the class, I forgot which one of you. What's the difference between adding that n sign and without n sign? Now you know that for casting, if you didn't put the n sign, you will commit the serious crime like what I did in the last 2 minutes. And such that I actually create a copy which has become the new type, and then which the effect of what you call that the virtual function is not being set up correctly. Okay, so we're okay so far. So now I'm going to do further changes. I'm going to think. Let's go to IoT thing, and I'm going to remove this virtual. I'm going to remove to virtual. And I'm going to think I also remove the virtual. So now it's no longer a virtual function, but it's a regular function. And other than that, everything is the same. It's still having that, I still have that casting to thing, right? So let's actually try to compile it. And then try to run it. Now you see that connected is gone. I don't have the connected because the call by reference, the casting of the reference, I converted to a different type, and then it's no longer IoT thing. So that's just show you, you can actually play around with this program to kind of enable you to understand what virtual function is doing with your code. Yeah.
And now if you remove the end, it should still be, it's still going to be connected. Right now it doesn't matter. It's no virtual
Right.
function to
Right.
override.
Right, it's no longer virtual function. So adding n and without n, in this case, is the same. But it's just one is reference, one is a copy. Yeah. Yeah, sometimes C++ is I guess when I say adding n doesn't make a difference because the program behaves the same. If I'm not using this as a virtual function, but the virtual function is going to make a difference. Okay. All right, good. Okay, any other question? If not, I'm going to turn off the recording and then just turn the session into question. Okay, yeah, please.
I'm not sure what the difference is.
Okay, you're saying that you have a multiple layer, right?
Well, right now you added the casting with the reference. Can we see it without the statement?
Oh, I got it. Sure. In this case, it should be the, oh, okay. In this case, it will actually behave to the IoT thing, because now this one is IoT, right? Switch nibble is IoT, so I don't do the casting, I make it. You run it, now you have a connected back, right? Yeah, it actually, it's just you play around with the casting and the virtual function, you can determine what kind of. Okay, so I'm going to stop recording and then please stay here if you have any question for me.